FastBlade is a new facility which will be the world's first dedicated structural fatigue testing facility for tidal turbine blades.
Currently, there's no facilities designed specifically for testing tidal turbine blades. This is because tidal turbine blades can't be tested in the same way that wind turbine blades can be tested in fatigue. We have to load them hydraulically. This can be a very expensive process, so FastBlade enables up to 80% energy savings during the fatigue testing process, which means we can provide a much more cost-effective service to tidal developers in their testing needs.
By partnering with Babcock, we've been able to take advantage of their fantastic manufacturing and design capabilities, as well as being able to locate FastBlade in an industrial facility.
What this project really does is make sure that developers have access to affordable and efficient tidal blade testing, and this translates into lower costs in making renewable energy.
FastBlade can answer questions such as, how does a blade perform after a million cycles of life? This is not something that current facilities are in a position to offer, precisely because FastBlade has a new hydraulic system that enables us to deliver a million cycles within a reasonable period of time, say 3 months.
Being able to provide this fatigue testing enables clients to de-risk their turbines by testing the full life cycle before their turbine's in the ocean, so understanding when the turbine might fail, when servicing might be required, and minimize their design risks by identifying possible failures during the testing before deploying their turbines out in the ocean.
I think one of the more innovative technologies the FastBlade offers is the hybrid testing. Combining with our advanced numerical modeling techniques, advanced monitoring, and the self-reacting frame for experimental testing, we could combine these components together to carry out real-time numerical simulations together with the testings. Therefore, we are able to get more accurate and more precise answers. At the same time, look for the ways that we could reduce the cost of the experiments.
FastBlade actually collects the data in two main ways. One is with single sensors of measurement, so we can attach different sensors to the specimen and to FastBlade itself. Also, we have a second way in collecting data, which is through digital image correlation system that we have. In this way, we collect the data of the whole blade itself. That led us to analyze more area, and we use just the single measurement points to calibrate this information. In FastBlade, we can test many different specimens. We are not limited just to tidal turbine blades. We can test beams, bridges, basically any sort of a structure that is large enough to fit on our frame.
When we're designing tidal turbines, the main design driver is the marine environment. So the combination of tidal current, waves and turbulence can be extreme. And seawater has over 800 times the density of air, and this can generate huge forces on the blades, the powertrain and the turbine support structure. Testing the tidal turbine blades would allow us to de-risk the route towards larger and more efficient designs that we can produce in larger numbers for commercial arrays. We designed the turbine for a 25-year operating life, and for it to do that reliably in a cost-effective way, we need to be able to support that with test data. As a tidal turbine blade designer, I think that FastBlade will allow us to continue to increase confidence in our designs and improve their performance and reliability.
FastBlade is the first part of the Gibb Innovation Campus, which is being developed here in Rosyth in a partnership of universities, Babcock International and public sector bodies. The aim of the Gibb Innovation Campus is to develop technologies and upskill the workforce of the future.
FastBlade is many things. First of all, it's a research facility developing new technology. Secondly, it's somewhere where we can train students, the next generation of engineers, in how to do structural testing and structural test design. And thirdly, it's an opportunity for the community to learn about engineering.
I've been working for the last 10 years on the development and design and manufacture of composite materials for tidal turbine blades. The development of FastBlade now means that we can bring these ideas to reality.